with us BIBHUTIBHUSAN sir from Government College Sundargarh. Now I request sir to deliver MEC-03, that is quantitative method for economic analysis, block 1, and today's topic is introduction to differential calculus. Sir, over to you. Thank you.
Thank you, Veda. Good morning to all learners. I am BIBHUTIBHUSAN SAHOO. I would say in Government College Sundargarh, but now I am transferred and posted to Government Women's College Balangir. So really, I am sorry that on a particular day I could not got the connection, so I failed to deliver this class or deliver this lecture. So I have got this opportunity once again to deliver some facts and the points that is related to the MEC, that is 03. And in this MEC block, we shall study block 1, in which we have 3 sections. In the unit 1, we have the functions, limit, and continuity. In the second units, we have the derivatives and differentiation. And in the third unit, we have the total differentials, partial derivatives. So dear learners, as a student of economics, we are always related with the different real events which need the mathematical applications. And here mathematical applications do not confine to the pre-SS level, that is the algebra, geometry, and arithmetic like. We have to deal with certain advanced mathematics, that is the calculus, and calculus comprises the derivatives as well as integration, differential equations, and likewise. So as the time is very limited, let me try to just divide our time period to 3 units and try to complete it within this stipulated time period. So dear learners, from the micro theory or any other application parts, we know how to find out the marginal cost, marginal utility, maximization of profit of a firm, marginal revenue, whatever may be the subject that we have learned in the microeconomics. That becomes easy with the applications of mathematics. And here mathematics means that is the calculus, or what we call the derivatives. So before going to this calculus section, that is the differentiation, we have to know the various concepts that is related with this differentiation. These are set, limit, and continuity. So everybody has some basic idea on sets, because it is a subject dealt even at the high school level. So simply I wish to give you only a brief idea about the set. Set implies this is simply a set of well-defined object. Well-defined object. That means whenever we are talking about the jewelry set, So in the jewelry set, we have a necklace, we have the bangles, we have the earpin, and many things. And they are the distinct items, and they make the total set. Each and every item in the set is known as element. This is known as element, and every element is well defined. So when we talk about the set of real numbers, the real numbers comprises from 1 to n, any natural numbers. And these numbers are well defined. If we say set of integers, then it comprises the values from negative to positive and likewise. So our objective to know the set is to find out the relationship between the set of two variables. Let here set of x, and here we have the set of y variables. But our objective is to go for the calculus. So I'm not going to find out the different operation of this set. So when we have the x certain variables, these variables may have certain relationship with the y variables. So the variables, you know, the quantity which varies. The quantity which varies is known as variables. So let x as 5, 6, 7, 8, 9. That means these are the domain values, or all the elements in this series is the domain. And for this domain, if we relate it somehow, we make some relationship with y, then we may have certain values which is related with this x. And here the values or variables in the y is known as codomains. They are known as codomain. And with that objective relation, we can find out the values or variables which is matched with this relationship. So they may be the finite number, they may be infinite number. And when they are related to the variables in certain relations, we may find out certain values which are known as a range. So the variables in this series X is domain. Y variables that consist of different variables is codomain. And the variable which is related with the X with certain functions, certain relations, then that is the range of variables. So variables may be discrete variables, variable may be continuous variables. In continuous variable means if it takes certain values within an interval, then that is the continuous variable. Or if x takes all possible real values from a given number a to another given number b, from a to b within this range, any number that comes within the interval a to b is called the continuous variable. So when we express the function, because when we express the relationship of x with y, we may have the variables that may be related within this boundary let. Let a, this is the boundary. So x may be within the limit a, because here I have given the symbol, it is greater or equal to a. That means a is the minimum limit. So a can be any natural number. Let it is 5. So value of x can be 5 to the minimum. Less than B, let it here in the B, it is 10. That means here the value of the variables within the interval is given and they are closed. They cannot exceed the 5 or they cannot exceed the 10. They cannot be less than 5 or greater than 10. And any value within this range is the continuous value of this variable x. And this type of expression is known as bounded but closed variables, because the upper limit and lower limit of the function or variables is known. Now suppose I delete this or simply make it greater or less. Then do we have any limit values? It is x is greater than a, but how far greater? It may be within the range 5, but there is no such limit. It may be 4.9, 4.91, 4.99, 4.9999. Likewise, for this b, there is no limit like 10. So when the variables of the value of a variable has no given limit, then that is known as open limit. That means there is no terminal value. When we express the variables in terms of greater or less, then they don't have any terminal value. So when it is closed, we expressed in this type of square bracket. When they are open limit, we expressed it in terms of this type of bracket. So it can be a combination of both in regards to the value which is open and which is closed. So we are only concerned up to this point from the set theory, because we are not much concerned about the set or operations of the set, how this set is related to our calculation. And from this set, as we know, the limit is given. If the boundary is given or closed value is given, then we can find out the variable. So before finding the values of variables, let me give a brief example. Suppose let y is a function of x, that is 2x square minus 1 divided by x minus 1. So to explain this, you can reduce this as a 2 into x square minus 1. This is x plus 1 into x minus 1. So x minus 1 can be cancelled. So this is 2 into x plus 1. So how limit works, then let me see. Let x tends to be 1. Tends to be 1 implies it is not exactly 1. It is something less than 1 or something greater than 1. For example, take some lower value minus some negligible value delta. So 1 minus delta, it may be 0.0, 0.01, 0.011 and likewise. Then we have the different value. If it is minus 0.1, then it is simply 9. If it is 0.01, then it will be 0.99. If it is 0.001, then it will be 0.999. Then what will be the value of this? If x tends to be 1, then multiply substituting the value of x in this example. So if x is equal to 0.9, then it will be 1.9 into 2. 1.9 into 2, that is 3.8. It will be 3.8. If it is 0.99, then 9.99 into plus 1, that is 1.99, then it is 2. 819. Likewise, you can find out the different values. And again, as I have told you, x tends to 1, it implies it may be less than 1, may be greater than 1. So it may be like 1.1, 1.01, 1.001, and likewise. When these values will be put on this formula, 2 into x plus 1, then also we will get that value. And that value will be approximation to 4. Because 2 into, this is x almost to 1. 1 plus 1, 2, 2 into 2, that is 4. That means it is not exactly 4, but it tends to be 4 when x tends to be 1. That means here the limit of the value, limit of the equations, limit of the functions will be 4. So by applying the different formulas, by applying the algebraic solutions, we can find out the value of different algebraic equations. Then what is a constant? What is a constant? Then a constant implies a particular value which retains the same numerical value throughout the mathematical operations. When we operate it mathematically, the value or numerical value or the algebraic alphabet which do not changes, then that is known as constant. That means here let y is equal to a plus bx. So here a is a constant value. It do not changes. The value changes for this because with the change in x, this will change. So it may be in the form of alphabet or it may be in the form of numbers like 1, 2, 3, 4, whatever may be the number. So when we use the different algebraic functions, we may come across the constant values, or this is a constant numerical value or constant alphabet value, which is remain constant despite of change in others. Then what is a functions? Because our objective is to know the relation functions and continuity. So by functions of x defined for a given domain is a quantity y which has a single and definite value for every value of x in the domain. That means if y is equal to function of x, then y have certain definite value when we put the value of x with certain relations. And here the function of x, it may be simple algebraic functions, linear algebraic functions, polynomial functions. That means if in the form of equation let a0 plus a1 x1 plus a2 x2, likewise, then y is related in this way, where a0 is intercept, a1 x1 a2 x2 are linearly related with the y. So with the change in the variables, quantity of variables x1 x2 and likewise a1 a2 and others, we can find out the different quantity of y. So there is a functional relationship And this functional relationship is expressed in terms of equations. And here you can see why the value of y is dependent on the value of these different variables x1, x2, xn, and likewise. So from this we can say x1, x2, and other are independent variables. They are known as independent variables. And here y is dependent variable, or the value of y, magnitude of y, quantity of y depends on the independent variables. So this equation form, it may be linear, it may be non-linear. We can express or we can represent it in the form of a graph. So let how to represent it in the graph. We have also, let me take the example. Why this is the demand for commodity. The demand for commodity is equal to 10 minus 2Q. This is a demand equations. 2P. Demand for the equations with the change in price, demand for commodity changes. So what is the intercept? Intercept means for any value 0, this will be the quantity. Price, if 0, then maximum demand will be 10. And this 10 is the intercept value in the vertical axis. So in this vertical axis, this is let 10. So this is intercept. And this 2 is the slope. That means this is 2 by 1. That means 2 for every 1. 2 for 1. And when it increases, there will be only 1 diminishes 1. So when we connect like this, we shall get the demand curve. Because it is negative, that's why 2 by 1 means that is the rate of decline is 2 unit per 1 unit change in the price. So this is how you can express. This is the slope. This is the slope. This is the intercept. So by taking the different values, we can represent it in the form of graphs. Again, the functions can be the inverse function. So inverse of a function is equal to, let if y is equal to function of x, then inverse function is equal to x is just inverse. Inverse means this is just f to the power minus 1. This is y is a function of x, and this inverse of this function, that is x is equal to f inverse. How it is? You can see fx means f into x divided by f. So divided f is equal to just f inverse and 1. So function can be the inverse functions. Functions can be bounded, unbounded, and line. So we have different functions: constant functions, polynomial functions, linear functions, rational functions, non-algebraic functions, and likewise. So I have explained you what is the limit, how to find out the limit. But the point is whether there is the continuity of functions. When we are talking about the continuity of functions, a function is continuous continuity of functions. So in the case of continuity of functions, intuitively a function fx is continuous provided its graph is continuous. That means when you draw a graph line, we do not have to raise the pencil or pen. There is no break in the graph. Then how can we know whether the function is continuous or discontinuous? So for this, we can take any variable x, and if for any limit, let x a tends a minus some delta value. That means this is the neighborhood value, what we say. When we take the value of x limit a minus some delta value, that implies we have some value towards the left. When we take x tends to be a plus some delta value, but delta is very negligible, then it gives us the certain value towards the right. Any value neighborhood to the a, that is the x, where functions a, fx is equal to fa, fx is equal to fa with the neighborhood value, that means tends fx a minus delta tends to be a, and fx x tends to be a plus delta, that also implies a, that means neighborhood value is continuous with this x. So when they have this type of approach, then there is existence of continuity. For every value of x in its domain, it is said to be continuous throughout this interval. When we take a minus delta as certain value, a plus delta as certain value, and that intervals has certain continuity. And this continuity of function is required because we have to calculate the change in particular values, change in the dependent variables by some marginal change in the dependent variable. Or what we say derivatives, that is the ratio of incremental variables. So you might be knowing some properties of the continuous variable. The sum or difference of two continuous functions is a continuous function. Properties of continuous functions. Properties of continuous functions. The sum or difference of two continuous functions. Sum or difference of two continuous functions is a continuous functions. Is a continuous functions. The product of two continuous functions is also product of two continuous functions is also a continuous function. The quotient of two continuous functions is also a continuous function. If function x is continuous at x, which is equal to a, then if function of a is not equal to 0, then in the neighborhood we have these values which are continuous in nature. So these are some brief ideas regarding our sets, limit, and continuity. Now let we move to our second unit, that is the derivatives. That is the derivatives. Then what is the derivatives? the increment of a variable x in changing from one value to another is the difference obtained by subtracting the first value from the second value. That means, for example, the incremental value, let y1 is something, some quantities, and y2 is another quantity. So what is the changed quantity? Yt can be any number, any quantity, y1 is any quantity. So change or increment is simply y2 minus y1. Changed quantity is y2 minus y1, which we can represent as delta y, change in the. Very often it is also represented by any other values like h, k, any quantity or numbers also. So if in a function y is equal to fx, the independent variable x takes an incremental delta x or h, then delta y or k denotes the corresponding increment of y of fx. That means let here y is equal to function of x, where x let 2x square plus 1. That means y is related, which is a function of x, and this functional relationship is like this, 2x square plus 1. And here the y is related to the quantity x or variable x. 1 is constant. Whatever value, whatever magnitude x takes, y will not change. Y, this constant will not change. And we want to find out the y or change in y by changing certain x. Then how can we represent it? So y is dependent variable and it is dependent on the quantity of x. So if x changes by a certain quantity like delta x, then how can we represent this? So y will be changed by delta y. So is equal to 2, as this is a function of x square. So we can write it as x plus delta x the square plus 1. Because the value of y depends on the square of change in x quantity. So originally this was x. Now when we change x by delta x, so the x will remain x plus delta x to the power 2 or square or polynomial 2. Then what is the delta y? Delta y will be equal to 2 into x plus delta x plus square plus 1 minus y. So y can be written as fx. Y can be written as function of x, which is equal to this. So now our objective is to know what is the rate of change for unit change in x. So how can we know? Because this is the delta y, change in y, due to the certain change in the delta x. But our objective is to measure the rate of change in y for every unit change in delta x. So we can find out this rate of change delta y by dividing delta x. Delta x can be any quantity. If it is 2, then divided by 2 so that we can get what is the change in delta y for 1. If it is 0.2, then also we can find out what is the rate of change, because 0.2 is equal to 2 by 10. 10 into this divided by 2. So from this, if we divide delta x on both sides, we can find out the rate of change or the ratio of change or rate of change of y for every unit change in the x. So can we find out what is the values? So in this example, if it is 2 into x delta x square plus 1 minus fx divided by delta x or h, whatever you can write, delta y, where delta x tends to be 0. That means when change in the quantity of x tends to be 0. So as I have explained you, tends to be 0 means it is not exactly 0, but we can say it is equivalent to 0. For example, 0.01, 0.001. So they are certain positive quantity, but it is very negligible. So when we say it tends to be 0, that implies it is not exactly 0, but seems to be 0. So by taking this type of deviations, we can find out what will be the value. So by applying the rules, that is x plus delta x whole square, you can find out x square plus 2x delta x plus delta x square plus 1 minus here this, that is 2x square plus 1. So getting this 0 and dividing it both by delta x, we will find out the value as 4x. So you might be knowing how to find out, or for simplicity, let me explain how. Y is equal to let x square. And our objective is to find out delta y by delta x. So we call differentiation in various name and used like symbol d of fx. This is also the definition. dy over dx. This is also the differentiation. F dash x or f prime x. This is also differentiation. If in somebody's f dash x, f prime, f dot x. These are the different expressions used by different mathematicians to find out the derivatives. So derivatives means to measure the change in the quantity of dependent variable for a unit change in the independent variable. And that is the ratio, that is the expression delta y by delta x. But delta y means y is the dependent variable, x is the independent variable, and delta y delta x can be written as dy by dx. This can be written as f prime x. This can be written as f dot x. This can be written as d of fx. So we can use all these in different notations, but interchangeability do not change the meaning. They are remain same. So let how to find out this. Let y is equal to function of x, which is equal to x square. Then what will be the change in the y? So delta y or change in the y will be delta y plus y when x changes, or x plus delta x square. That means when x change by delta x, where delta x limit, delta x tends to be 0. Limit x tends to be 0. So delta y will be what? Delta y will be equal to x plus delta x plus whole square minus y. So minus y can be written as fx, as y is equal to fx, which is equal to x square. So we can write it as x square. So by taking the whole square, what is this? X square plus 2x delta x plus delta x square minus x square. This is absolute change in the delta y. So minus x square. This is equal to delta y is equal to 2x delta x plus delta x square. Taking the delta x as common, you can write it as 2x plus delta x into delta x. So to know the rate of change, delta y by delta x, so divided by delta x cancel. As I know, have mentioned, value of delta x tends to be 0. We can substitute delta x is equal to 0. So the delta y by delta x is equal to simply 2x. That means delta y by delta x is nothing but the derivatives, or simply we can write it as dy by dx of x square, that is function of x, is equal to 2x. So this is how we can find out the derivatives of the functions. So what is this derivatives? As you can find out, here the exponential of the x. To find out the derivatives, you can see the exponential of the variable is the coefficient. Here 2 is the coefficient, and the power get how much? 2 minus 1. That means here it is 2 minus 1. That is equal to 2x. So to find out the derivatives of a particular function, you have to take the power, take the exponent as the coefficient, and take or subtract 1 from the exponential, and whatever is the remain, that is the derivatives of a particular function. So when we have a function, and that function is in the form of addition or subtractions, the derivative of that functions with respect to independent variable is the derivatives of their different terms. That means the rules for derivatives is equal to the dy by dx of let function x where x is equal to 5x square plus 3x plus 3. So in this case, we can take the derivatives of every term separately. That means dy by dx is equal to d dx of this plus d dx of this plus d dx of this. So when the function is in the form of addition or subtractions of a polynomial's functions, then in that case, we can find out the derivatives by taking the differentiation of each term separately. Then what is the differential coefficients? Before going to other functions. So differentiation of a coefficient is the process that is followed. To find out the derivatives is the differentiation of coefficient. So to a definite finite limit with delta x tends to be 0, then this limit is called differential coefficient or derivative of fx or y. Whatever is the process followed, that process is the differential coefficient. So we have the different rules to find out the derivatives of different functions. So when the function fx is in the form of addition or subtractions, then we follow the derivatives of different terms separately with respect to dependent variable. When the function is in the form of product, or multiplications, then how can we find out this? That y is equal to something u and v, uv. So in that case, we can find out the derivatives, or we can find out the differential coefficients by applying the rules u dv by dx plus v du by dx. To find out the derivatives when it is in the form of product, we apply the rules, that is u dv by dx, when y is a functions of uv, then dy by dx is equal to u dv by dx plus v du by dx. অর্থাৎ multiplying the u absolute value with the derivatives with dv with respect to x and plus v getting the derivatives with respect to u, we shall get the derivatives of products. Again, when we use y is a functions of x, which is a quotient, that means if y is a quotient of u by v, then in that case we can find out the derivatives dy by dx. The u and v are the functions of x, then that is equal to u, that is v du by dx plus u plus v du by v du dx, then u dv dx divided by v square. That is when the expression or the function is in the form of quotient, then in that case we can find out the derivatives by using this formula. Again, there are certain different special cases. When it is in the form of exponential power, let e to the power x, this is an exponential form. In that case, if y is equal to this, then you can find out dy by dx by simply taking this eu, this will be simply ex. But if it exponential or e to the power 2x or x square or like y, then in that case it will be the function into du by dx. If you take this as u, let me make it clear. E is equal to x square, y is equal to e. Then take u as x square, So you can substitute it at EU. Then how can you find out dy by dx? So in this case, dy by dx will be equal to what? Dy by du into du by dx. This is what is the chain rule. By using the chain rule, you can find out these derivatives. That means dy by du is equal to e to the power x square. Du by dx is equal to 2x. So this will be 2x e x square. So we can find out the derivatives of exponential functions like this. How to find out the derivatives of a function that is y is equal to a to the power x? Then in that case, d dx, but dy by dx is equal to d dx of this, which can be written as a to the power x log ea. So when base is a, e simply, then that is called natural logarithm, and that is expressed as ln e or ln x. Again, to find out the log d dx of log x is simply equal to 1 by x. D dx of sin x is equal to cos x. These are the different formulas, trigonometric formulas. You can derive also. So d dx of cos x is equal to minus sin x. D dx of tan x is equal to sec square x. D dx of cot x square x cosec square x. Then constant with 0. Derivatives of any constant is 0. So we can find out the derivatives or differentiation by taking the different we can get the derivatives of addition or subtraction by taking the derivatives of individual items. We can find out the derivatives for the product rules. We can find out the derivatives for the quotient. We can find out the derivatives for the logarithmic functions. We can find out the derivatives for the trigonometric functions and likewise. So by applying these rules, we can find out the different values or differential coefficients for the different types of functions. So now let we move to the next unit, that is the total differentials and partial derivatives. Partial derivatives or total differentiation, but total differentials. Total differentials. Now suppose, so far we have discussed the functions is a single variable functions. That means one is the independent variable which is related with the dependent variable, and the dependent variable is only one. One thing I have left, the different application parts of the derivatives. In the first derivatives or differentiation, we have certain application parts. So these application parts, we can find out the marginal revenue. That means when, let me just revise this first. By applying the derivatives, we can find out the marginal revenue. So how can we find out the marginal revenue? The total revenue is equal to P into Q. So marginal revenue is DTR of DQ. DTR of DQ. Likewise, we have the total cost functions. Total cost functions is functions of different cost of different variables. So by DTC by DQ, we can find out the marginal cost. And even to find out the elasticity of demand, that is the price elasticity, we know P by Q into dQ by dP. So dQ by dP is the derivatives, Q with respect to P, and taking the ratios, we can find out the price elasticity of demand. We can also find out the relationship between different variables: average revenue, average marginal revenue, average cost, marginal cost, by applying these derivatives tools. And one more important thing, by using these derivatives, we can find out the value of maxima and minima. Maximum and minima, or maximization as well as minimizations. So from the different convexities or concavity, we can find out the maximum value, minimum value of the functions. By taking the first order derivatives with respect to independent variable as 0. And for the maxima, the second order conditions will be negative or less than 0. And for the minima, second order derivatives will be greater than 0. That means to maximize the drop profit, let d pi by dq is equal to 0. To minimize the cost, dtc by dq is equal to 0. So in the both the cases, first order condition is 0, and this can be found out by the application of derivatives. But to know the maximum or minimum, the second order conditions for the maximum, then second order is equal to j square pi by dq square is less than 0. And for the minimum, d square tc by dq square is greater than 0. And as you can find out the second order conditions or second order derivatives, we take the cube, then it will be the third order derivatives, and likewise. So in this way, we can apply the derivatives to the application part, and we can find out the different values in our economic analysis. So next, let me move to the last unit, that is the partial derivatives and total differentiation. Partial derivatives and total differentiation, but total differentials. So far we have discussed all the functions are related with the single variables. Y is equal to function of X. But now let's take Y is an area of a rectangle. So in the rectangle, we have the length and breadth. That means Y is a function of L and B. There are two functions, two variables. When we take the area of a cylinder, then we have pi r square h. There are three variables. And our objective in the partial derivatives is to find out what is the impact of a particular variable, or due to the change in a particular variable, what will be the change in the dependent variable. Now suppose Y is a function of X or U and V. As quantity of Y depends on the quantity of U and V, how can we measure the change in the Y due to the change in U or change in V? By simply taking the partial derivatives. So in the case of partial derivatives, what we shall do? We shall take the derivatives with respect to a particular variables, considering other variables is remain constant. In the case of partial derivatives, we take the other variables as constant. Let y is equal to x square plus 2z square plus c. And when we want to study what is the impact of change in x, if y is a function of x and z, and c is a constant value, let it is number 5 major. Let it 5. If we want to study the impact of x on y, then in that case, we have to consider that z is remain constant or z do not changes. That means in that case, we use this symbol, del y by del x, where z is constant. Then as if z is a constant value, without changing the quantity of z, we want to measure the value of y. That is expressed as del y by del x, where z is constant. That means only x is changing. Suppose we want to measure the change in y due to the change in z, then in that case, it will be del y by del z, where x is constant. That means we take the derivatives as if it is a single variable case, considering other variable is remain constant. So in this case, first order derivative dy by dx can be written as simply fx. If we take the differentiations to or second order, del square y by del x square, then it is fxx. If we take the second order derivatives, del y by del x, because we can take the cross derivatives as well, then it will be fxy. So when we take the variables, one which is changeable, then in that case, other variable will remain constant. That means here, even though function is a multivariate function, even though function is related with many variables, in the case of partial derivative, we find out the derivatives with respect to a changed variables, provided other variables are constant. So when the constant of variables, we take the derivatives of a constant, then that is 0. Likewise, it is applicable in this case. So in the case of partial derivatives, we only take the variables which is changeable and other that is remaining constant. Then what is the total differentials? The formula for total differentials, that means when a function is related with multivariables, then change in the dependent variable due to the simultaneous change in the other variables. When we study the change in the dependent variable with the simultaneous change in other variables, then that is the case of total differentials. And the formula that is used for different types of cases are also different. Let in the case 1, for the case of total differentials, in the case 1, suppose z is a function of u. Z is a function of u, where u is a function of x and y. Z is a function of u, and u is a function of x and y. Then what is the total differentials here? So we write total differentials is equal to dz. Total differentials is equal to dz, and dz is equal to simply what will be this? F prime u du. Dz is equal to f prime u du. This is the case 1 where z is a function of u and u is a function of x and y. Then dz is equal to f prime u du. Then what is this dz by dx? So dz by dx is equal to what? Dz by du. Dz by du, apply the chain rule. Du del u del x with respect to, because here x is the variable where y is constant. Likewise for dz by du, the dy, dz by du, then this is dz by du into del u by del y. So we can find out this derivatives or total derivatives dz by using this del z del x, this plus del z du, because this is the del z del x. So when the cases are different, this is one case. Now let's take the case 2. In the case 2, suppose z is a function of x and y. Z is a function of x and y, and they are also functions of some independent variable t, where x and y are functions of independent variable t. That means x is a function of t, y is also a function of t. In the second case, Z is a function of x and y, and again x is a function of independent variable t, as well as y is also a function of independent variable t. Then in that case, total derivatives, but total differentials dz is equal to del z del x into dx plus del z del y into dy. And here we have the functions. Y is a function of t. X is also a function of t. So what can be dx by dt? Dx by dt is equal to phi prime t. Dy by dt is also this, let f prime t. Dx by dt is equal to this. Dy by dt is equal to this. So we can write out dx is equal to dt can be multiplied here, dt. Likewise, dy is equal to, you can multiply dt here. So now substitute these values, del z del x, let me write, dz is equal to del z del x into dx. In the place of dx, I shall write as t into dt plus dz del z del y del y into prime t. I have substituted the values of dx and dt. So now take the dt as common. Taking dt as common, we can write dz by dt is simply del z del x phi t phi prime t plus del z del y prime t. And again, we can find out phi prime t is equal to simply dx by dt by substituting dx dt, dy dt. You can write del z del x into dx dt plus del z del y divided by into dy dt. So this is the formula that can be used to find out the total differentials when z is a function of two variables x and y, and both x and y are the functions of an independent variable, that is t. This is the second case to find the total differentials. In the case 3, if z is a function of x, y, where y is a function of x, z is a function of x and y, where y is a function of x, where y is a function of x. That means z is a function of x, y. And again here y is also a function of x. Then in that case, total differentials dz is equal to del z del x into dx plus del z del y into dy, or simply del dz by dx is equal to del z del y, because by dividing dx on both the sides, when z is a function of x and y is a function of x, then dz is equal to del z del x. This is partial derivatives with respect to x into dx, plus this is the partial derivatives with respect to y into dy. But again, we know y is a function of x, so we have to find out dy by dx. Then dz by dx divided by dx divided by dx divided by dx. So dx cancel. So dz by dx is equal to dz del z del y plus del z del y into dy by dx. This is del z del x, not dy. Del z del x plus del z del y into dy by dx. So this is the formula when it is the case of differentials where z is a function of two variables x and y, and again y is a function of x. In that case, we can find out the total derivatives or total differentials by applying this formula, that is dz by dx is equal to del z del y plus del z del y into dy by dx. So in the case of 4 IV, how can we find out? Suppose z is a function of x and y. Z is a function of x and y, where x and y are themselves functions of two independent variables. Z is a function of x and y. X and y are also the functions of two independent variables. Two independent variables, that is u and v. That means x is a function of uv, y is also a function of uv. U is a function of y, uv. Assume that all functions have known partial derivatives. If we know the partial derivatives, then in that case, dz, but total differentials is equal to del z del x into dx, del z del x into dx plus del z del y into dy. Del z del x into dx plus del z del y into dy. But as I have told you, x is a function of also u and v, y is a function of u and v. Then how can we find out dx? So dx is equal to dx du into du plus dy du into du. Likewise, dy will be equal to dy du into du plus dx du into du. These are the partial derivatives. And by putting these values, we can find out the total differentials. Now, suppose these are the independent cases. Then can we have a function which is completely expressed like this? There are certain functions in which we cannot find the y is a function of x. That maybe y is somehow implied by x, and likewise y implied x where x implied x. That means there may be the case of implicit functions. There may be the case of implicit functions. So when there is implicit functions, we have to find out if y is functions of x, and likewise then take the dy dx of total equations on both the sides. Dy or dy of this dx So take the derivatives of x with respect to y on both the sides. Then bring all the dy by dx into one side and take the values into other and find out the dy by dx. When it is the case of implicit function, that means we cannot completely express the y as a function of x. So let this 10x square plus 5xy square plus 3y is equal to 10. So in this case, this is an explicit function. X and y are presented in the explicit forms. So in that case, you take the dx by dy on both the sides and get the values. Take the common of dx and dy, and then you will get a particular value. So this is how you can find out the solution to an implicit functions. Again, when we are talking about the total differentials, we can apply it in our economic analysis. So you might be studying the elasticity of substitutions in the case of production functions. That is constant elasticity of substitutions. Elasticity substitution of 1, that means Cobb-Douglas production functions, CES production functions. In that case, we can use these total differentials. Likewise, we can use these differentials in the case of homogeneous production functions and to prove their properties. So this differentials derivatives calculus has a special applications in our economic analysis, and the economic theory is made easy by applying the mathematical tools. So basic knowledge on mathematics, and mostly that is the derivatives, total differentials, our integrations, differential equations, difference equations are necessary for a scientific and rational, reasonable analysis of economics. So I think I have covered the 3 units in that block 1, and within this paucity of times, within this limited times, I have tried my best to touch all the points. However, how far it is acceptable and you have accepted that is the point, you know. Or anybody, if any have any questions or any doubt, then I can take some time to clarify the different issues. So in this case, I have followed the total study material of Odisha State Open Universities, only partially referred the other books, I think, which will be make the analysis easy.
Thank you, sir.
Okay, madam.
The class was very informative and interesting. I hope every student enjoyed today's session and learned something new, including me. Thank you, sir. Thank you.
Okay. Thank you.